Alright, boys and girls, here's the first part of the video on 3.10 iNumbers. This is the teacher copy. Remember, the whole purpose of this video is to show that these sets are closed under operations of addition and multiplication. I say addition and multiplication because subtraction is just adding the opposite and division is just multiplying by the reciprocal. Here are how all the sets are arranged, and you really need to understand this. Naturals are part of the whole numbers, which are all part of the integers, which are all part of the rational numbers. And the rational numbers combined together with the irrational numbers are the real numbers. These are the numbers that are on the number line. Okay, all the real numbers are all the numbers on the number line. And then, because of our last task, taking the square root of a negative, we get something called complex numbers, the stuff that has the imaginary number I in it. So I'm going to just really quickly go through the answers and explain to each of these conjectures, and then come back and show how the sets are closed. Okay? So here's the answers to the first three conjectures. It's always, always, sometimes. So two integers is always an integer if you're summing. The sum of two rationals is always a rational. The operations are closed. That means the answer you get when you try some possible sets, that means it stays in that set of numbers. And then it says the sum of two irrational is sometimes an irrational, because what happens if I subtract and get back to 0? I think that's a special case. Even though it's not irrational, it's still a real number. So you're staying in the real number line. Okay? So again, these operations or these sets are closed under addition and multiplication. Okay? Let's do this next part right here. See, we have real numbers, complex numbers, integers. Okay, for these first three. And so it's sum, product. That's addition and multiplication, always, always, always. So you can see the three answers. They're always going to stay in that set. So those sets are closed under addition and multiplication. Now when it says the quotient of two integers, quotient is dividing. You're multiplying by the reciprocal. The time when you don't get an integer is when you make it a fraction. But it's still a rational number. So in other words, we're still closed. The real numbers are still closed under addition and multiplication. Okay? Number 8, 9, and 10 also serve to hammer home this point. So product, quotient, product. Okay, we got rational, rational, irrational. It says these two are always, so the product of two rationals is always a rational. And the quotient of two rationals is always a rational. So that's really nice to know. And then the product of two irrational is sometimes, because you can go square root of 2 times square root of 2. This is the example I always throw out at students. Square root of 2 times square root of 2. Those two numbers are irrational, but they equal the square root of 4, which is an integer. Okay, so it's not always an irrational number. Okay, and that's the end for this video. I'll show you the rest of the answers and the vault notes in the next video.